This is the bash one-liners and other tools to simplify MySQL ops at scale. Much like my title on this, forgive the definition of what one-liner is because it can be very long when you're dealing with bash, but just giving you a little forewarning on that. I'm Brian Cain. I work for Dropbox. I'm based out of the Seattle office, and I'm one of the MySQL SREs. Basically, I'm a combination of database engineer / admin, as well as have to do some amount of development work. I work in Python and a little bit of bash off and on as kind of the main things that I work in. Dropbox has over 5,000 production MySQL hosts running at any given time. So we are big on automation and can't afford much in the way of downtime, obviously, if you'd like your Dropbox files to be accessible. So a lot of the stuff that I'm touching on today are just little one-liner tools that I might use from time to time and wanted to share with you. A few notes as we're going through on the agenda. I'm going to go through some of the common bash commands that I'm using. Now, this is not all-inclusive, but it is a pretty decent list. A scenario I'd like to go over is when you run into too many threads running on your MySQL host, and some of the things you can use with bash to kind of narrow things down out of your process list or show engine innodb status, etc. And then some random, hopefully useful one-liners that you can use. As you'll note, as I'm doing some of these demos, I'm actually going to be doing them on a live Dropbox host. So some of the commands will look a little bit different than I'm running, just because they're not, I've got generic ones in here for you to use, like MySQL-E, whereas I'll use MSQL root for the username, and I'm not giving the password, obviously, for everybody to copy. But that's embedded in our tool set, so I can actually run live stuff. So you'll see a few differences here and there, as well as I've got a process list and an engine status saved away. So don't mind that I'm typing cat proc list, when obviously that's not what you'll do when we go live, when you're doing this live. So we'll get, and a couple admin things just so I don't forget them at the very end. I've got a little bit of swag up here at the front. And also, just so I don't forget, we are hiring. We don't have a posting for a DBA position, but it is open. Just there's no official route to it, but I do have business cards I can leave you if you want to apply. So we'll get started. So when I'm working in bash, a lot of these different tools that are built in are things that I find particularly useful. grep's probably the one that you use the most. It's how you search standard input. You've got ways to organize it with sort and unique. You've got ways to modify it with awk and sed and tr. You can tear apart lines with cut. You can put lines together with paste. And then you've got all sorts of extra tools. And all of these are ones that I'll go through examples of either separately or as part of a larger whole. But a lot of these are not things that you may have ever used before, or if you have, you don't use them very often. And I'm very much in the same boat. So the man pages on all these things come in really useful. So another thing I want to set as a kind of a baseline here is there's always more than one way to do things. So if you have a particular tool that you like to use, you can certainly come out to the same output or same objective just through different means. So as an example here, I've got a sample list that's a 1 through 5 on separate lines, and I want to get to the point of 1, 2, 3, 4, and 5, comma separated on its own line. Well, I've got 4 different ways just demonstrated here, and I'll run through these real quick. But basically, and let me grab the laser pointer. So First one, we'll be looking at paste. That's how you can just paste lines together with a separator. TR is how you can translate lines or translate characters. In this case, we're taking the \n and replacing it with a comma. And then we're going to append or turn that last comma into a new line. awk is a powerful tool. It lets you set variables as well as do if-then statements within it. So we'll run through a few of these real quick just to give you a sample of that. So, and this is where we'll see if everybody can see it from the back. So my sample list is just 1 through 5. Is that big enough for everybody? Okay, good deal. So if I ran that through paste and I give it a comma for a separator, I get 1 through 5, like that. The next example was that I'm going to use that TR. So I'm going to translate the \n, the end of line on each one of these lines. I'm going to put a comma in place of it. And if I just ran this, I get 1 through 5 with a comma but no new line. So I can use the powerful tool sed, which will do substitution of the comma at the end of the line and turn that into a new line. And now I get 1 through 5 properly lined on its own line. Let me so show you here. Now the other two here with awk, so rather than run through the first awk here, this is basically, let me get this out of the way. Again, this is setting a variable in awk, so it's basically saying what's my output separator is a comma. Print 1, well actually, I'll go ahead and run through it. It's worth running through. So if I do this awk v ors equals comma, and, thank you. And I do print $1. Now with awk, it's looking at fields within a line. So the very first field within the line is going to be number 1. If I do that for sample list, I get 1 through 5, comma separated instead of separate lines. And again, I can use that same sed trick in order to drop it off the end. And then I've also got that other awk here. Rather than try and type that out and possibly make a mistake, basically to walk through it, it's basically saying, so if my first field is not empty, I want to do something. So within that, if my first row that I look at, NR is the number of rows or number of lines I've processed, the first one of those, then I want to just print the number. If it's beyond the first one, then I want to print a comma and then that field. And then finally I wind up with, we'll go ahead and run this. Again, I wind up with 1 through 5, but this time with no comma on the end because I'm only putting a comma before each of the subsequent fields. And then rather than use that same sed trick that I did before, this time I'm going to do paste and use paste like we did before, but now with nothing specified, which means just paste this new line to a carriage return effectively, and I wind up with the same output. So, like I said, there's a lot of different ways to do this. So as we're going through different exercises, if you find a better way, that's great. And if you find a less efficient way, that'll happen too. So as a scenario, if you have too many threads running on your host, there's a lot of different root causes to that. A couple examples would be that you have an overwhelming number of fast queries. So basically you're just making the server run too hot. You have a smaller number of long-running queries, because basically your running count's going up because you've got a bunch of them that are running for 10 or 20 seconds or what have you. You could have lock contention because you got an alter table going or a select for update that's blocking other transactions. And another one that we run into occasionally at Dropbox is semi-sync replication delay, where you're waiting for the acknowledgement from the replicas to say that they got the replication event and could pass it back, and then they can go ahead and commit back to the client. Well, if it's waiting on those, you're basically piling up a bunch of things waiting on those commits to come in. So because you've got all these different possibilities of things that are going on, your process list can basically lead you in a good direction on what's going on. So we'll look at how we can use that with Bash. So first off, one of the things you can do is figure out, how bad is the situation? What is it that maybe is the cause of it? Is it sleeps? Is it a lot of queries running? Is it waiting on semi-sync? What exactly is the problem that's going on? So what I can do is I'll run basically this, but with a sample. So my process list, first thing with a process list is, and apologies for switching in and out because I don't have two screens to work off of. So right off the bat, in your process list, you start out with your header information. I don't want header information mixed in with my results. So one way to do that is you can use tail and basically tell it to start at the second line going down rather than from the bottom working up. And if I do that now I get that same output but without that header. So if I then want to go ahead and grab this fifth field being whether it's sleeping, it's bin log events, it's some queries, what have you. I'll do awk print $5. So now I get, it sleeps, it's bin logs. If I sort those, and then I use unique to get a count of each, and rather than do it just the first set, I can see now that out of my process list, I've got only 6 bin log events. So basically I have 6 replicas running off of this one machine. I have 8 queries, and I got 949 sleeps. So we need to investigate some more and figure out, well, is it the queries that are causing the problem because there's just a few really slow ones? Or is it there's some active transaction going on that's gone to sleep, but it's blocking other things from being able to run? In this case, it's very likely going to be the queries themselves as opposed to sleeping transactions. So to look at what are my top 5 longest running queries, we can basically use that same process list, tail to get rid of the header information again, but now we'll grep to get rid or to only include, in this case, use egrep for basically an expression of case insensitive, select with a space, insert with a space, update with a space, or delete with a space. So it'd be one of your DML actions, and then see what we'll sort those by the 6th field being time, and we'll sort it as a number in reverse order, and we'll only take the first 5. So we'll kind of run through that. So start off with, we're catting the process list, we're getting rid of the header, we're doing this egrep, and select, space, insert, update, and delete. And if I were to I'll just run this because I know there's only 8 in this list. So basically I have a one update, and I have a number of select star from very large table. So these select star from very large table happen to have been running for 125 seconds, 127, 124. So if I were to in turn sort those by that 6th field and only the 6th field, then I'm going to wind up with them normally in ascending order, but I'd like to make sure it's treating it as a number and put it in reverse order. And I only want the first 5, so I can use head to only get the first 5. So I get these 5 select star from very large table queries. So that can at least help me see, what it is. And in this case, they all happen to be the exact same thing. And again, like as I was saying, there's more than one thing to do these some of these operations. And for the purists out there, there is a way to write this using the process list table from information schema, where you're only grabbing queries, ordering by time, descending, limit 5, which is great if you'd like to type that out versus show process list with some bash commands. But taking advantage of the fact that you do write this sort of stuff out, now you can do things to kill those queries. So let's say that select star from very large table is a new feature that's been released by the application developers, and you want to prevent that from bogging down your machine while they're fixing it or making an upgrade to the code to remove that without a lack of a where clause. So in order to do that, you can actually write a while loop that would go out and find those specific queries and kill them. And we use this off and on because it's more important to keep your database up than it is potentially to get some selects back on something that's not going to return before a web page would time out anyway. So we'll run through that real quick. So here's basically the internal part of that process. So we've got, looking at my process list, and here, let me clear the screen and bring it back up so it's a little clearer to read. So in this case, we're grepping specifically for this select from very large table out of the process list, and we're going to print basically the kill commands that we need. And the way we'll do that is using the first field from awk, which happens to be the process ID from process list. And if you use a kill with that, that's how you can basically eliminate that process from running. So just running it, I'll get kills for those process IDs. And then all I would have to do with this example was pipe that into MySQL. It'll take those kills. It's going to sleep for 1 second when it goes back through the while loop, and then it'll look for them again. Or you could sleep it for 10 seconds. Let's say that they do make the change finally, and they've added a where clause, and I don't have anything looking for the where clause. And the where will now make it run in less than 10 seconds or less than 5 seconds or what have you. I can make my sleep longer, and then when they fixed it, it'll stop killing them, in theory. Or at least it'll kill fewer of them, and then they'll tell me, and then I can turn it back off. So that's how you can kill threads associated with a query. But let's say that it's not something so obvious. Let's say those 8 weren't there with all those very large tables, but it was part of our 900 and some odd sleeping transactions, which if something's sleeping, it could very easily have started out as a begin work. It's done some operation, it's done an insert or an update or something else, it's locking rows, but now that it's sleeping, I can't figure it out. I don't know which of those which are sleeping to get rid of. One thing you can, as an aside, take a look at is the engine status and see what transactions are actually running at that time. So we'll take a look at that. So if I were to, and again, I've stored this in an engine stats. So if I looked at engine stats and I wanted to, I'll just start with engine stats. Sorry. And I jump down to active. Oops. These are all in the transactions list. This would be all the active transactions within the engine status. So you can see there's various ones with different values. We got 0-second ones, and if I go all the way down to the bottom, I've got a 12-second long-running one, a 10-second long-running one. But you can kind of see in here that this transaction, even though, like, for example, this one's active, it doesn't tell me anything. It doesn't tell me what the statement was. It just says that write user is in the process of cleaning up. Well, one thing you'll notice, too, with transactions is, in general, you've got one line with the active. You've got another line with some information on how many rows are involved, and then another line which will generally be what that statement is or what the activity is on it. So if I wanted to, I could take a look at those specifically and grep for active. And also a thing grep has is you can add 3 more lines after whatever it finds. So now if I run this, you can see there's just slews of transactions going on, but I get to see just these active transactions that are in here and some of the information associated with it. So if for using that information, I can see all these things are sleeping, the active transactions don't have any useful information for me to go off of, I can use that same sort of process we talked about earlier for killing off these connections. And in this case, I'll just grep for sleep and then further narrow it down, because within each of these, you can see they're all associated with the write user. So I can just kill off write user sleeping transactions. So get this out of the way. As an example of that, it would basically be the same cat, the engine status, grep for sleep, grep for write user. Oh, sorry, it's not the process list, not the engine status. Process list, grep for the write user, awk, print, kill, $1. And then I would pipe that to MySQL, and basically there's my big long kill list to get rid of all those sleeping transactions. That one I would not put into a while loop, because you've basically killed all the connection pools and everything else. But odds are, if it's sleeping, it's from an application standpoint, they should be able to recover whenever a connection's dropped. But more importantly, I'm taking care of somebody left something uncommitted for a long period of time. Again, they should be able to recover from that. But it's more important I get my database back up in a healthy state. Nope. So this one I'll just kind of touch on real quick, and the reason I've given you this is sometimes, like in the engine status, you'd like to be able to see just a section, or out of the slow query log, or some other output that you're getting from either MySQL itself or some of the other tooling, how can you just yank one section out? Now, in the, we'll go back and take a look at the engine status again. So let's say I wanted to look at the deadlock section. So I've got this fairly healthy deadlock section in here that is telling me that in this case, we're running PT table checksum. It happens to be checksumming against a particular table. At the same time, the chunk it's operating against is the same one that's getting an update statement. Between the two of it, it got a deadlock. It decided to kill the update. Yeah, so on and so forth. Well, that's great if this happened to be 5 days ago, but if it happened a couple of seconds ago, maybe I want to keep double checking to see if that deadlock section is changing over time. And it's hard to, pull this up, scroll down to it, take a look at it, and see what else is going on within it. So I've given you a sample of a way to actually go through this that entire output, where in this case you're feeding the show engine innodb status into a while loop. The while loop is reading it a line at a time. We're starting out with a variable print it, which is basically to say whether or not I want to print a given line. So if print it was 0, which it's not going to be the first time through, so we'll skip that section. I'm going to echo whatever that line is, that very first line, and I'm going to feed it to grep. Now grep's got another feature, the -q, which is quiet output. What that does is it does not actually print what it finds. It gives you a return code of 0 if it found it, or 1 if it didn't. So print it is, and then $? Is, give me what that return code was. If it did find it, which would be equal to 0, I want to actually print that line, and then go ahead and continue through my loop. Now, if I printed it once, now print it set to 0. So now it means the next line, then I go into this if loop. Again, I'm going to now look to see if I find transactions, which is at the other end of that block. So if I do find it, I look at that return code, which I set into stop. If stop is equal to 0, as in not 1, or not 0 yet, I'll continue printing the line. But once I actually find the transaction section, I'll actually break out of my loop, break out of processing this, and now I can actually grab that whole section. So rather than type that out, oops. I'll actually just run that as a demo. This one's deadlocks. So basically, deadlocks just printed that out, and all I did was run this thing that I had up in the presentation. So basically, I got started with latest detected deadlock, printed every line after it until it finally got to the transaction section, which comes after this set of hyphens here. And then on top of that, then you could grep out whatever it is that you might be interested in, like say how long ago was that, if you wanted to see just this time, to see if this time is changing, you could just grep for the time, or tail for that time specifically, or one of a dozen different ways you could just grab that time specifically. So that's how you can pick a section out. So that was our scenarios part. So now I want to kind of go into some of the other hopefully useful one-liners that you might get some value out of. And how are we doing on time? So let's say I wanted to look at my disk usage on a particular box. And I'll use as an example, I want to see how big my bin logs are. So what I can do is I can use du for looking at disk usage in bytes for a given set of files. For a given set of files, I use awk again to print out that first field, which is the byte size. I'm going to paste pluses in between them. So in other words, I'm going to add those values up. I'm going to use sed to basically give it to this BC, which is a calculator. And what I'm doing is I'm basically saying at a scale of 3, so in other words, I want a precision of 3 after the decimal place, I'm going to take all those added up files, divide it by 1024 3 times, and then finally I'm going to wrap that in how many gigs that was. So I'm going to run that as a quick demo as well. So this one is disk usage. So basically, for all that output up there, I've got 101.024 gig worth of binary logs on this machine. And all it was doing was running this deadlock section again, the disk usage. And again, it was basically just summarizing all of the disk or the sizes of those files, adding them up, throwing them to a calculator, calculating it out, and then I threw G in there just so I know what scale it was that I had left it at. Another thing that might be of use to you too is, let's say normally you're running at 80% of disk used on a given host, and that's including all your binary logs, relay logs, et cetera, et cetera, et cetera. But you get a disk warning that your machine's about to fall over because it's run out of disk space. Well, you can use LSOF to look at the list of open file handles and use that against your temporary directory to see if you've actually got a condition where someone's running an extremely large select with some sort of order buys or group buys or whatnot that are generating temporary files or a lot of temporary files for a lot of queries, to see if that is what's eating up the space. Because if you go out to take a look at what's effectively a deleted file, it will not show in an LS. It won't show in any way that you can actually take a look at it normally. So I'll give you a quick demo of that as well. So which one is this? Deadlocks, disk usage. Oh, not disk usage, sorry. Sorry, I apologize. I was just going to type this one out. So I do this LSOF command, and I'll just do a head on it. It basically gives me the size of different files that are out on the file system and where they are. This is basically all of the open file handles that are out there. But if I grep for just the ones that are using my temporary disk or temporary tempdir within MySQL, and I sort it by the size, that's actually going to show me that, MySQL D out here is using these various files in this tempdir, but they're all deleted, which means that the file is deleted, but the file handle hasn't been closed, so it has not released the disk space yet. So I could potentially have some sorts that are very large that are still out there eating up space, and I need to maybe kill my sleeping transactions, or kill a query that's still out there that is eating up all my disk space. Network traffic. So one of the things that Dropbox uses is proxies. So a proxy for us is basically going to be allowing us to have, let's say we have 100,000 connections that are desired to hit a given master. That could be 1,000 machines, each with 10 or 100 default connections that they all want to open. Well, I don't want to allow 100,000 connections directly against MySQL because that's a ton of overhead. So we use proxies so that we'll take all those connection requests and narrow it down to, say, 1,000 connections actually against MySQL. So the first thing you can take a look at was, and as we'd seen before with the process list, is how many of these are actually out there and where are they coming from. So let me jump out to a live machine and we'll actually do a live check. So process list, skip the header, n+2. In this case, we're going to look at the third field. The third fields are what host is the connection from. And let me just get the output for that real quick. So if I look at the output for that, I've got a couple coming from localhost, some from 127, some from 1048, 1042, so on and so forth. So if I was to, much like we've done before, if I sorted those and then I took the whole list and made it unique, I'm going to effectively wind up with a pretty long list that's got like 127.001, but it's also got a port number in it. Well, I don't care what the port number is. So what I can do to add to that is before I sort it, I'll actually use cut to get rid of, or to only keep field 1 with the semicolon delimiter. And now, basically, and I can get rid of less at this point. So now at this point I can see I've got almost 1,000 coming from 127 and a few coming from localhost. So basically that's a symptom of our proxy, in that everything's connecting to our proxy, which also is located on this machine. And so it is actually interfering with me figuring out where traffic's coming from. So what I can do then is I can actually look at the 3001 port, which is one of the ports that our proxy operates on. And I can use SS, which is basically a sockets list, or a much like netstat. It's going to give me all of the open connections against my box. So we'll do that. So we'll use SS. We'll look for that specific port. Number 5 happens to be where the source of that connection is, and it too is using a port with the IP, much like the process list. So I'll narrow that, sort it, unique it, and in this unique count it. And in this case, I know there's going to be a whole lot of variation, so I'm just going to look at it in sorted numeric order just to give me this list, because I can see I've got 80 from 1048.54, another 81 from 58, another 81 from 50.54. So if I had an extremely large number coming from a single location, I could maybe backtrace that to see how many, what's going on. Was it a new app released or whatnot? You can use resolve IP to figure out what that host is and maybe figure out the owner and go from there. This one too, since I'm running a little short on time, I want to make sure I get some questions in. I'll just kind of skim through these last couple. If you were, let's say you've got different tables, you're running on a sharded environment where you have multiple databases with the exact same tables everywhere, different contents within them, but the basic definition is the same everywhere. If you wanted to make sure that those definitions are the same, at least at a high level, you can run this bash one-liner, per se, where it's basically going to go through and look at the show create table statement on each one of them. And what it's going to do is, so I'm connecting to a given host. I'm looking at all my databases named shard. Of those databases, of each one of those, so that's shard 1, shard 2, shard 3, so on and so forth. I'm going to loop through each one of those. I'm going to look at the show create table for, in this case, the table change set. One thing that's going to be different between each of those is if there's an auto increment column, that auto increment value is going to be different all over the place. So you don't want that to say that things are different. So you can use sed to basically remove the auto increment field, and then it will in turn do a comparison as it's rolling through this loop to see if any of them are different or not. And if it does find that, you know, one table is not the same as the next shards table, it'll tell you that there was a mismatch, and otherwise it'll say there was a match. And like I said, I'm running out of time. I'd like to run through that in more detail, but that'll give you a head start on if you'd like to do those comparisons. Also, sequences. If you, let's say you didn't need to figure out dynamically what shards it was you were going through, you can actually specify a sequence list. So in this case, I'm going every 8 values from 0 to 63. And I can generate my shard dynamically that way. Or if I've got somebody who's like our edge store system, it uses binary numbers as representations for those sequences of shards. So you can actually use BC again and convert those into binary numbers. So you can instead get incrementing values that way as well. And then finally, one of the other things that we do for scale is we use GSH. GSH is a tool that's out there and available. We've got our own version of it because we use it with our service discovery system. But basically, you can use GSH to run parallel SSH commands across multiple hosts. And in this example, I would be checking to see if any of my replicas have fallen behind, so I get how many seconds they are behind master out of my show slave status across what could be, in this case, I've got it set up to run up to 256 parallel executions based on how many fit this criteria of our fake shard system within our SJC metro. So basically that's it overall. I apologize for not quite deep diving into those last few, but are there any questions? Did I overwhelm everybody?
You will post slides?
All slides are already posted, yes. Yes.
So where do you maintain or curate this collection of one-liners? Presumably with the larger team, will each have there will be some divergence over time.
I keep them in a home directory, basically. Because if something gets sufficiently useful, we'll actually write Python or something else that would be more from an admin full-on tool perspective. But when it's things that are, I use this every once in a while, or I'm in the process of, let's say I needed to roll out a schema change across 500 machines, I might write this sort of bash tooling to generate all of my alter statements that have to be slightly different based on which shard they're applying to. So I can generate this big long file, and then I can GSH grab each one that goes to a specific location and run all those in parallel with screen and all that other good stuff. So that's kind of where the often sometimes useful principle of the one-liner stuff. So
How many MySQL servers do you have?
over 5,000 that are running at any given moment, over 6,000 if you include the ones in our spare pool. So yeah, it's some of our clusters can be over 1,000 just of a specific type with different shards throughout. Usually it's got the same number of shards per, where I can use sequencing like that to say I want to run on every 8th shard or every 4th shard, but sometimes it's not, in which case I use the dynamic way of determining which shards there are to build that sort of a for loop. Cool. Okay. Well, yeah, if no other questions, feel free to stop up to the front. I've got my other swag I didn't get in time, but I've got a little bit of goodies up here, and if anybody's interested in working for Dropbox, grab a card from me. All right. Thank you.